In the last video, we started looking at custom devices, and we made the point that you can create a custom device by either starting with your own data logger and adding essential InsightCM processes, or starting with our source code and modifying it to your application. We looked at the top level VI for the source code and discovered that the architecture is made up of mainly relatively lightweight parallel processes that all talk on the same message bus. And while it does make the code more modular, it can make it kind of hard to see where the data is flowing and how all these processes interact with each other. Well, in this video, I'm going to discuss data flow between these processes and introduce something called the data flow script. So let's start again here with our tower of processes here, and let's go through the flow. The way the source code works is data starts off by being read from the FPGA. Then it is passed to the virtual channel process, where integration is performed if configured. Then the data is passed to the accumulator process, where custom data block sizes are implemented. Then the data is passed to the analysis process, where features are calculated. Then the data is passed to the triggering process. Then the data is passed to the alarm process down here, where alarms are evaluated. Then it's passed back up to the TDMS creator process, where it's logged to disk. Then it is passed down to the tag publication process. And then finally it is passed to the test panel. Raw data is passed around in this fashion, but files have a flow also. Once the TDMS creator creates a TDMS file, logs the data to disk, and is done with the file, it passes it to a process called the Data Explorer Helper, which adds InsightCM Data Explorer specific properties. How do I know that data is passed to all these processes and in this order? Now, if all of these processes pass data to each other directly using queue references, then you could just open them up and look. But with InsightCM, data is not passed using direct queue references for reasons that I'll explain later. These processes pass data to each other using something called a data flow script. And again, I'll explain more about this in a moment, but bear with me, and let's start by opening up a VI that's referenced by the top level VI called initialize dfscript.vi. What you'll find inside of this VI is that it builds up a list of processes. Each of these VIs holds a string constant with the name of a process. And so what's happening here is this initialize VI is building up an array list of all the processes that are to receive data and in which order. And this becomes our data flow map. So we have one map here for our waveform data, and then we have a second map here for our TDMS file. Now, why do we only have a list of 8 processes here instead of 9, and only 1 here instead of the 2 that I showed you in the previous screen? It's because with data flow, you don't have to define the originator of the data, just how it flows once it's been created. So this VI builds up a map of which processes are going to receive data and in which order. Now, if we go to these processes, they will all have something in common. They will all have a case called process data flow block. And they will all have a VI called next. So what happens is each of those processes in the map will receive a message called process data flow block and receive the waveform data when it's its turn. And when it's done processing the data, it will pass it to this next VI, which is responsible of moving that data to the next process on the list. Now, why do we do it this way? The idea is that this extra layer of code actually makes it easier to modify the top level VI and insert new processes into the data flow. So for example, if you were going to insert a process between the analysis process and the triggering process, you would need to modify the analysis process to send data to the new process instead of sending it to the trigger process. So the data flow script is intended to break this dependency and allow you to insert processes into the data flow without having to modify the upstream process. So the idea is that you could insert the name of your new process into the map instead of directly modifying the upstream dependent process to use a different queue reference. So one thing that you have at your disposal that can help with this is that anytime that you need to add a new process to the source code, you can start with our template. Now I'll open this VI up in a moment, but the SDK does provide a process template for custom devices that use the same queued message handling API, that has the same initialization and shutdown strategies. It handles errors in the same way, and it uses watchdogs in the same way as our regular InsightCM processes. So this allows you to insert new processes that the controller knows how to interact with and that can talk on the data flow script. So let's go ahead and I'll show you where that's at right now. So at C, Program Files, National Instruments, LabVIEW, Examples, InsightCM, there is a directory called Process Template. And this is just an LV lib. Now if we open that up, you will see that it is full of several VIs, but the main one that I want to highlight now is process.vi. This is the code that you just saw in that screenshot. And if you notice, it has the key case called process data flow block. So this thing is already set up to talk on the message bus and be used with the data flow script. Now I will have a video series that is devoted to the adding of a custom device from beginning to end. But for now I just want to make you aware of this template, of something called data flow script, and why it exists within the source code.